Can you tell that if a candle is lit in a very big closed box, then after the candle is lit, the weight of that box will decrease or will it remains the same? So in this video we will understand the law of chemical combinations and also find the answer to the question asked earlier. To make any new compound, the elements have to combine with each other. And how the elements will combine with each other, it is decided by these 5 rules. The first rule is the law of conservation of mass. In any chemical reaction, the mass of reactants is equal to the mass of product. Suppose we burn 1 kg of coal, then the mass of ash left after the burning will be less than that of the coal. But many other gases are formed while burning, like water vapor and CO2. When we add the mass of these gases and the mass of the remaining ash, then their sum will be equal to the mass of the coal. Now if we look at the question asked at the beginning of the video, then a lot of gases are released even while burning of a candle. And when the candle is lit in a closed box, then all those gases will be present inside that box. And there will be no change in the weight of the box. Its weight will remain same as before. If you are thinking that the candle will be extinguished due to lack of oxygen, then let me tell you that we have put extra oxygen in that box so the candle does not extinguish. Second rule, the law of definite proportions. According to this law, a given compound always contains exactly the same proportion of elements by weight, irrespective of the source it comes from. For example, 2 samples of cupric carbonate, one taken from natural source and other synthetically made in a lab. The percentage of weight of copper, carbon and oxygen in both the samples will be same. Third law is the law of multiple proportions. According to this law, when any 2 elements combine to form more than one compound, such as hydrogen and oxygen combine to form water and hydrogen peroxide as well. Now if we take 2 grams of hydrogen for these 2 compounds, then to make these 2 compounds 16 gram and 32 gram of oxygen will be required. So if we find the ratio of the mass of oxygen in both the compounds, we will find that their ratio is in whole number, 1:2. This is because when an element combines with another element, it combines with 1, 2, 3 or 4 atoms. They never combine with half or 3/4 of the atom. The fourth law is Gay-Lussac's law of gaseous volumes. According to this law, when gases are combined or are produced in a chemical reaction, they do so in simple ratio by volume, provided all the gases are at the same temperature and pressure. As we can see in this example, 100 ml of hydrogen gas and 50 ml of oxygen together produces 100 ml of water vapor. So in this case, the ratio of volume of hydrogen and oxygen is 2:1, which is a simple ratio. So whenever hydrogen and oxygen combine to make water vapor, the ratio of their volume will always be 2:1. We can understand Gay-Lussac's law better through Avogadro's law, which we are going to see after this. So the fifth law is Avogadro's law. According to this law, at the same temperature and pressure, if the volume of any gases are equal, then the number of total molecules in those gases will also be equal. For example, at the same temperature and pressure, 1 liter of hydrogen and 1 liter of oxygen gas will contain equal number of molecules. So Gay-Lussac's law becomes clear from this law, that at STP 50 ml of oxygen will contain half the number of molecules as compared to 100 ml of hydrogen gas. And to make water, we always need half number of oxygen atoms than hydrogen molecules. Now let us see what is atomic and molecular masses. Atomic mass unit, that is the unit that measures the mass of an atom. 1 AMU is equal to 1/12 of the mass of C12 isotope of carbon. And if we write it in grams, then it will be 1.66 into 10 to the power minus 24 gram. We denote AMU by small u, which is also called unified mass. The molecular mass is equal to the sum of atomic masses of all the atoms present inside a molecule. For example, the molecular mass of one methane molecule is equal to sum of the masses of one carbon atom and 4 hydrogen atom. But in some substances, the atoms are arranged in this way that it becomes difficult to identify a single molecule. As we can see in this 3D structure of NaCl, one sodium ion is surrounded by 6 chloride ion, and one chloride ion is surrounded by 6 sodium ion. So in such a situation it becomes very difficult to identify a single molecule. So in this case we use formula mass. And in this condition the formula mass of NaCl will be equal to the sum of atomic masses of sodium and chlorine. So that's all for now. Hit the like button if you liked this video, and for more videos like this do subscribe this channel and don't forget to press the bell icon. Next we will understand the mole concept and percentage composition.